final presentation for Engineering 113 Group 7, Project R.O.B. Hello, my name is Simeone. I'm in Group 7 of Engineering 113, and today I will be presenting a final animatronic, Project R.O.B. Now, in this presentation, we will cover R.O.B.'s background, the abstract, project overview, technical activities and progress, challenges we face, and the end product, and what we will be doing moving forward. Well, what is a R.O.B.? A R.O.B. is created in 1985 as an accessory to the NES and the Famicom systems. And in recent times, he's been included in the Super Smash Bros. Series, which is how it became the focus of our design project. In this project, the group is being tasked with creating a themed animatronic that can perform coordinated movements using Arduino programming and motors. We chose to replicate R.O.B. from Super Smash Bros. Series. The main goal of this project is to create a working R.O.B. that performs multiple actions while it is still true to its original source material. These actions include moving around on tank treads, which are housed in the bottom with most of the other hardware. And we also have the torso, which moves side to side in a spinning side V motion, which is one of R.O.B.'s moves in Super Smash Bros. We also have the head, which has flashing lasers, which are made by blue LEDs. Some features were cut and postponed due to time constraints. One of them was RC control. We bought an HDO5. We never got to use it because we didn't know how to implement it. We didn't have time to implement it. Coordinating lighting system, we had some trouble with the lighting in Arduino, and battery power. So we couldn't find a way to power the robot with batteries. We ended up pursuing making these features work instead, which are a coordinated DC motor drive system, working in tandem with a stepper motor and powered body spin, separate battery-powered LED system with an on-off switch. So we made a lot of progress, especially after the midterm oral presentation. And some of these things include a sturdy frame of wood and PVC, or 100 custom cut pieces of foam board to coat the exterior, correct wiring maps, code for proper animatronic functionality, and paint to make our animatronic as true to the source material as possible. Besides our final animatronic, our group worked on multiple secondary deliverables, such as proof of concept prototype, which was made at Connects, pseudocode, machine sketches, and a website. In the end, this was our budget. As you can see, it came out well under $200. We also faced multiple challenges during the course of this project, one of which being no physical contact with our group mates. We also had to make multiple trips from each other's house to pick up supplies that didn't come in our kit but came in their kit. We also had too powerful of a power source at one point plugging it into a wall, which caused wires to burn up and smoke. We also had to troubleshoot code, which big thanks to Zach Chin for helping us out with that. We also had a problem where there wasn't enough torque from the DC motor since we weren't hooking them up to a gearbox. And when we did hook them up to a gearbox, it couldn't attach itself to the tank tread gear without rubbing against the tank tread. So we had to find a way to troubleshoot that as well. Also powering the LEDs was an issue, especially through the Arduino, which is why we stuck the battery power in the end. And we also had multiple long-term power outages in the home stretch, which definitely harmed our progress. So in the end, we settled on a R.O.B. that looked like this. For all that hard work, this is our final project. Came out better than any of us could have ever hoped for. It has DC motors on the bottom to move it around, stepper motor in the middle to spin the spine, and the LEDs in the head. They're controlled by switches on the back, a hold down switch made out of connects to control the LEDs, and a button on the also made out of connects to control everything else. Here's a video of it in motion. Moving forward, we have many ideas of what we're going to do. integrating a completely functional Nintendo Switch dock into the arms, and adding an RC control for all functional parts, adding independent head spinning functionality so that the head can spin independent from the spine, hydraulic arms, and maybe a bit more LED functionality to simulate the fuel on R.O.B's spine, which is how it is in the Super Smash Bros. Series. Now, let's return to the battle.
So, not only is R.O.B a completely functioning animatronic, he's also a very worthy adversary.